So today I'm going to talk a little bit about some observations, tips and tricks on reducing LLVM build times. As compiler engineers, a lot of us work with benchmarks day in, day out, spec, core mark, dry stone. But the benchmark I think we should really care about is how fast can I build LLVM, which particularly if you're hacking away on an LLVM backend, you can end up iterating quite a few times. So I've got a few stats here, kind of health warning. They're all kind of rough and for fun. I can't guarantee they're all completely reproducible, but I think are broadly correct. This is building on a relatively beefy desktop system, Ryzen 9 5950X, 16 cores. And I guess I've included kind of full build commands more for future reference and something I'll go through right now. And I'll pick through a few things that can be helpful for slightly faster incremental builds. Before doing that, this is kind of how a standard release build of LLVM, specifically Clang, LLVM, and LLD, with all of the default targets evolved over time. On the left side, you see the kind of most recent. This is just by building the first commit, or the commit on the first of every month over the last 18 months. The metric there is the number of LLVM builds per hour, going from, at the beginning of this month, around about a little bit over 5. To go back in time 18 months, you can manage a little bit over 6. And this is maybe partially due to LLVM itself getting a little bit slower, but a big part of it is going to be more code being committed, so there are more files to be compiled, certainly more table gen stuff as new backends that are added, like at some point in there, Long Arch became a standard backend, so it was built. A few other fun stats. We always like to compare ourselves to GCC, and it still is the case that Clang is a faster way to build Clang and LLVM. This is building with a kind of recent distro packages, getting about 5.4 versus 4.3 for Clang versus GCC. For this from scratch build of the release Clang and LLVM, I actually didn't see much difference between the different linkers, though this, as we'll see on the next slide, the stress on the linker is massively reduced for the release build versus debug builds, which, as you may know, if you've done work with debug builds, are absolutely huge. So this is just using CMake build type is debug, and then the parameters we're playing with are shared libs and split dwarf. So shared libs kind of does what it says on the tin, rather than linking all of the LLVM subcomponents as .a files into large binaries. You have Clang, LLC, all those tools linked dynamically to separate LLVM components, .so files. This isn't the default build config. It mostly works. It should work, but it does break every now and again because most of build bots don't build in this config. So it isn't all that unusual for a commit to be made that changes cmake list.txt. It doesn't properly include all the dependencies, but it works just fine on a non-shared build. As you can see, for a from scratch build, there's not a huge amount of difference either with shared libs or split dwarf. Split dwarf just separates your debug info into separate files. But if you start looking at a fairly standard incremental build scenario, so if you're modifying a single C++ file in one backend, in this case RISC-V ICEL lowering in the RISC-V backend, just going with the default build options, the incremental build is relatively slow, 100 incremental builds an hour. If you're stuck using, or you fail to switch away from using BFD, it's very, very slow, only 14 builds an hour. You're spending a huge amount of time linking. Shared libs, much faster, 400 or so. Split dwarf is a performance improvement, and then using both is the best. I should say there is a downside to using shared libraries, which is that the startup time for the individual LLVM binaries is increased, and you'll see that if you're running the full test suite. So there's, as with most things in life, there's no free lunch. It's a trade-off, and you also see that the table gen build times are can be dominate, particularly if you change one key file like intrinsics.td. That generates most of it, and these build settings don't make a huge difference. You're spending most of your time in table gen. There are settings that can help with that, like the LLVM optimized table gen. Warning there is that it's very easy to write incorrect table gen because most of the checking doesn't actually occur in the in the release build, and so it's easy to miss that if you're building with that. And there's a number of other things there to look into. So thank you very much. I'll be posting a series of blog posts soon that kind of go into more detail and also look at stats across different build machines. Thank you.